We are Team Alpha, and today we'd like to tell you a little bit about our project, Mori. Mori was born out of the need to support fast video manipulations under low bandwidth conditions. A typical use case of this would be a video-oriented social network that allows users to craft their own stories. Although our project is implemented as a video processing system, the concepts I'm going to discuss are much more general and are easily applicable to many other situations. This diagram represents the essence of Mori. My aim in the next 3.5 minutes is to convince you of the elegance of our solution from both a technical and a conceptual perspective. To start off with some key facts about our project. We took inspiration from an advanced audio manipulation program called Super Collider. However, since we were working with video, we faced a much greater complex technical design. So let's talk about input. Now the input can come from any source. For example, a web interface that looks something like the mock-up you see on the left. It offers the users the ability to apply some video editing functions in any way they choose, creating an arbitrarily complex graph of edits, where each node in the graph represents a function, one of the listed capabilities. We take that input and we use our own internal representation in order to construct and analyze the graph it represents. On the way, we do a number of checks to ensure the input is both valid and useful. Now we get to the heart of the problem, analysis. To tackle this, we define what we refer to as offloadable regions, or simply ORs. Mathematically, an OR is a pair of nodes satisfying these three constraints. Conceptually, it represents a unit of computation that we can offload without straining the network. In this graph, there are two ORs, one nested inside the other. The critical thing to note here is that we are only ever sending and receiving one stream of video thanks to the first two conditions. First, we apply this formula to all the nodes to determine the potential endpoints. After that, we do the same thing in reverse to determine the potential start points. The last thing to do is to match each start point to exactly one of its potential endpoints. After analysis, we have all the information we need in order to execute the graph. Implementing this was not at all straightforward. Subtext indented. The way to think about this is simple. Each node represents a function of one or more inputs, running in its own thread with its output passed on to one or more edges. Each edge represents a bounded buffer that is concurrently filled by one node, a producer, and emptied by another, a consumer. If the server is under load, it can choose to offload an OR over the network to some remote processing unit. For example, the client making the request. The computed result is then integrated seamlessly with the rest of the graph it came from. All this means we can have a lot of fun editing videos both quickly and efficiently. Thank you, Shia. So that, in a nutshell, is Mori, a dynamic and scalable server architecture designed for non-linear video processing. Thank you for listening, and good luck to the rest of the groups.